I got a mailbag and some packages that came through customs from across the pond. So we'll put these big things aside over here. Let's see what we got here. Oh, I got 1, 2, 3, 4, 5, 6, 7 packages. This says it is a guide tube. I know what this is. Guide tube. Oh shit, we don't know. Damn it. Oh, yeah. Get that. This is, I cut the bag. It's a PTFE tube, Bowden tube, with some Bowden couplers on them. Jeez, why are they so tight? Why can't I get these out? Oh, jeez, why won't these come out? Oh, they're pushed in too far. How do you get them out? That's not releasing them, it's just pulling it in further. Jeez, why won't this come out? I don't... There we go. Holy shit, man. I guess the first time you put them in, those teeth grab them real good. Yeah, I think somebody over-inserted them. You know, they just don't. What is the deal with this tube? Oh, it's like they're not releasing. It's pushing down the tabs, but I guess not enough. Huh. That's interesting. I don't know what the deal is with that. Yeah, you just gotta pull them off real hard. They really dug into there. I'm gonna have to cut these because I don't know what they did. They must have stuck them in and twisted them. They do not release like anything I've ever used. Probably because it's dug in there like that. So I'm going to put that back in this bag. And I'm going to put these couplers over here. I don't think these are very good couplers. Alright, Bowden tube. My Bowden tube's a little messed up, so I just got a spare. But I really just got these to connect to a filament box. So I don't have any at the moment, so I just bought one piece, but I'm probably going to get a couple meters of this because I'm going to build a filament box. Line times 1. This is a really long where's the end? I guess there's no connectors on this. This is just, oh, there it is. Just a really long rainbow conductor ribbon. Not sure how many, but description will say it. Next, instrument accessory. Oh. Okay, I have no idea what this is. It's obviously for a heat gun. I thought I was ordering a small kit for my heat gun. And this is clearly not small or cheap. This is really thick metal. I can't even modify this to do whatever. This isn't going to fit on my... This is for a large industrial heat gun. I don't know what I'm going to do with that. Oh well. I probably paid a good amount of money for that too. 5-volt PL05N NPN. Oh, I was like, what is this? This is a proximity sensor. 5 volts. It says 10 to 30 volts DC. It doesn't say 5 volts. This is a FOTEK. I think it's an inductive sensor, but I thought it'd be cool if I could add bed leveling, auto bed leveling to my printer. I thought I'd try this one. It's pretty cheap and pretty small. I like the size of it. All right. Let's see. Let's open this prime package. Oh, I just ordered this. This is a MAX31855 K-type Thermocouple Amplifier. Well, not amplifier, it's a SPI sensor. It does all the amplification for you. It's got this little connector. This is Adafruit. I bought this because I have one of these cheap ones. I bought one of these eBay ones. I had a really hard time getting it working. It was just not very susceptible to any kind of noise. In fact, I couldn't even use the serial port because it would completely change the numbers. It's very strange. So I finally got it working. I had to change it to a new board, and then I had to add a 10 nanofarad capacitor across the thermocouple lead. So there was two kinds of noise it was picking up, and anytime I had any kind of noise or LED lights on, the temperature would just change. The whole linearity of the sensor would change to like 30 degrees out Fahrenheit. And it was bizarre, and I could not get around it. So I got it working better now. I have a cleaner power on my ESP than I was using Node MCU. And it seems like the CP2102 puts a lot of noise on the line when you connect to it with serial. And I just couldn't get rid of it. I'm going to try it again and see if I can get it working. But I really want to get my reflow oven, toaster oven, set up to start reflowing. And I just could not get this to work. So after 3 days of messing with it, I just went ahead and spent the $15 or whatever it was to get an Adafruit one. I wasn't sure if this was a counterfeit chip that had lower noise immunity, rejection, and then it doesn't have anything on it, just a capacitor. They put level shifting, which should do a little bit of buffering. They put capacitors. They put well, they put some dropper diodes and stuff like that. It's probably not really going to help me at all. It might. But it's got its own regulator on it with nice decoupling, and then it's got RF, and it's got ferrites on the thermocouple and a capacitor across the thermocouple. So this should be really quiet, much quieter than this cheap eBay one. So we'll see how that turns out. I'll go ahead and start testing it later. I'll put that over there so I don't lose it. And this is just my light and sound board. I put this I-squared header on it so that you could plug LCDs into it. Or other, some other sensor, some environmental sensor or whatever you wanted to. The only problem is the 1.3 and the 9.6 version of these OLEDs have different pinouts. So only this one works. I think also the skinny long one works. It's ground, VCC, SCL, SDA, but you can swap those two in software. But you have to put it. You'd have to put it on the other side of the board or something if it was reversed. All right, so got that temperature set. I got that. I don't even know how this works. I'll have to hook this up and play with it. It says 1030 volt VC, VDC PL059, but when I got the package and opened it up, it said 5 volt PL05. It's kind of confusing. There's 3 wires. I'm going to guess power and out. Looks pretty nice. The wire looks nice and soft. So, if you put this on a machine, it's not going to stiffen up your assembly. I've seen these in different colors, so maybe they have different characteristics. I think I've seen a blue one. So we'll go ahead and I don't know what I'm going to do with this. Oh, jeez. I really wanted something that could melt heat shrink. This might work if I can make this smaller and I can just. Maybe my idea was to bend this around and make it a heat shrink. I don't know how you do that though. It's solid metal. It's not the thin stuff that it's made out of, and it's welded. It's like a muffler. I mean, it's thick. This is made to take a lot of heat. Oh well. So I'm gonna move the stuff out of the way because these packages aren't really gonna fit. Put that over there. So I got these 2 packages. These are from Tobias Stoeger. I got one, and then I got the next one a couple days later. What's odd is he didn't send them out at the same time. They got here within 2 days of each other, but I think they were maybe a week apart. So they must come all together through customs, or they must get delayed. Let's see what we got. This is awfully big. Hopefully it survived. It's a little ripped up. Yeah, it looks pretty good. I mean, probably needs thicker bubble wrap, but it seems to have survived. I think it was set priority, so I know what this is. Alright, so this is a turntable. But yeah, this is cool. Thank you for sending this to me. This is so cool. I think you can just print this yourself if your printer's big enough. Yeah. So you got that. All right, I got this other package. This says 2 Microwakeupper PCBs. This is also from Tobias. And these are 2 Microwakeupper PCBs. I think he sells these on Tindy. There's a and there's his GitHub repo. His username on GitHub is TSTOEGI, and this repo is /Microwakeupper. This is I think this could probably be used for a few things, but it's mainly made for waking up a microcontroller from various inputs. So like with the ESP32, you'd use the, you put it to sleep, and you can wake it up yourself in code with GPIO 16. Or you can accept an external input that pulls, I think, yeah, you're basically resetting the board. That's what deep sleep does. So it sleeps the board until you wake it up. And then it actually kind of comes all the way back up and goes all the way back down. And I think you put a pulse on the on the reset line. So this has it has the ability to do inversion. So it's got normally connected or normally open, NC or NO. Yeah, normally open or normally closed. I wonder what these 3 are over here. I don't know what those 3 pads are right there. They don't seem to be labeled. I'll have to look at the repo. I wonder if that's a jumper. Yeah, that must be the jumper. So I wonder what the jumper selects, because those seem to be the inputs for normally close or normally out open. But it almost looks like the jumper jumps between the 2 also? No. I'll have to look it up. So there's a jumper there. I must select between something. It gives you all the headers, and then one of these to use for either whichever one you're using, normally open or normally closed. And then over here you got STA, DIS, G16, RST, ground, and VIN. And I have no idea what these do. 3.3 to 5 volts in, ground, MCU reset pin, ESP GPIO 16, set high to disable switch, high if switched. It looks like you put some kind of really thin mounting holes. They look like maybe they're 3mm M3 hardware, and then some little pegs on this side so that you can screw and secure it. Something I forgot to do on my board. I only put 2 diagonal screw holes, and unless you have supports on them, the board just flops back and forth. Oh well. What are you going to do? So I'm excited to play with this. I will read the repo and find out how to use it, and we'll test it out. Looks like it's got a diode, maybe a reverse protection diode, some kind of little chip right here, CM01068, probably a Schmidt trigger. So I'll make another video probably working with this, and that's it for now. Till next time.